This is the screencast for section 5.4, example 6. We're going to find area using antiderivatives, which yes, we've done in the past. We've learned how to do this in a very straightforward way, but we have to be a little bit more cognitive of what kind of graph we're doing, because as you learned in the previous section, signed area is positive or negative depending on whether it's above or below the x-axis, and that means the integral sign. Whereas if the graph just tells you about area, it's just saying all positive. So we have to be careful. This example 6 says find the area of the region between the curve and the x-axis. So this is saying all positive. So let's think about what this graph looks like. This graph of 4 minus x squared, let's see, that's a parabola upside down and shifted up 4. So we've got, I don't know, something like that. And it's asking us to find the area between the curve from 0 to 3. Well, I know that 2 makes this function 0, so this is the point 2 comma 0. So I'm looking for area that's both above and below the x-axis. So in this situation, the integral from 0 to 3 of 4 minus x squared dx would not work. We need to break this into two separate parts. We need to make that part below the x-axis now positive. We don't want the signed area. It's asking us for make it all positive. Find the area of the region between the curve and the x-axis. Okay, so we're going to take the antiderivative then from 0 to 2, and that's going to be like normal, 4 minus x squared dx. But then we're going to not add, but subtract the integral from 2 to 3 of 4 minus x squared dx. We know that that piece is going to be negative because it's below the x-axis, so if we subtract it, it's going to make it positive. We're going to be adding this piece above the x-axis to this piece below the x-axis. Alright, so the piece above, the antiderivative will be 4x and then minus 1/3 x cubed, and we're going to evaluate that from 0 to 2. And then we're going to subtract the same antiderivative, so 4x minus 1/3 x cubed, but this one is going to go from 2 to 3. Okay, so let's start plugging in our upper limits and lower limits. So I have in my first piece the antiderivative evaluated at the upper limit 2, subtract the antiderivative evaluated at the lower limit 0. Now I'm going to subtract, now my second piece, first evaluated at 3, subtracted, now evaluated by 2, at 2. So now you may be thinking to yourself, sweet, these cancel, the ones at 2's, but they don't actually, because this is a minus negative evaluation at 2, so you actually have 2 of those 4 times 2 minus 1/3 2 cubeds. So now a little bit of mental math, and I get 7 2/3. Now try problem number 41, says find the total area. So again, that means all positive. We're not doing the antiderivative of just one blank statement. We have to think, is any of this below the x-axis, because that's going to change things. We're finding the total area of the region between the curve and the x-axis. So this curve is 2 minus x, so a line with slope -1 and a y-intercept 2. So I know that this point right here is going to be 0, 2. I know that 2, 0 makes the function 0, so that's the x-intercept. And I want to go between 0 and 3. So here's 0 to 2 above the x-axis, but then out to 3 is going to be below the x-axis. So I need to break this up into two pieces. The antiderivative from 0 to 2 of 2 minus x dx, and now minus the antiderivative from 2 to 3 of 2 minus x dx. You could have added the antiderivative from 3 to 2, because remember, reversing the upper and lower limit of integration also changes signs of the integral, so I could have just said plus the antiderivative from 3 to 2. That would have worked just fine as well. So now I'm going to find the antiderivative I'm going to, let's see, the antiderivative of 2 minus x is 2x minus new exponent of x is going to be squared, so that's a 1/2 x squared. That piece is getting evaluated from 0 to 2. And then I'm going to subtract the same antiderivative, but now this piece is going to be evaluated from 2 to 3. So I'm going to take f of b minus f of a over here in the first term, and then subtract the f of b minus f of a in the second term, which would be f of 3 minus f of 2. And a little bit of math will get me 2 minus 0 here, and then this is going to be, let's see, 1/2 minus 2 here. So I get a total of 2.5.